All right, so today we're going to take a look at under the week 2 objectives. We're going to look at some new draw commands: P-line, polygon, point, and donut. I want to discuss the file commands: new, open, qsave, and save as. And then if time allows, we'll get into some of the view commands: redraw, regen, zoom, and pan. And if not, I'll pick up with that on Wednesday. Okay. And then we'll be working, our goal then will be to complete lab 1 and get started on lab 2. So that's what we'll be dealing with on Wednesday's class, okay? And also, anybody wants to come in early, they can. I'm gonna be there earlier on Wednesday. So I think I'm coming in at noon, something like that. So shoot me an email if you wanna come in. And that way I'll know, to look for you, okay? Ian, since you're here, do you have any questions from last week other than what we just looked at?
Nope.
Okay, cool. All right, so we're gonna go on. We're gonna take a look at the draw commands: P-line, polygon, point, donut first, and we'll move on, okay? So firing this up. Can you see everything all right? Good?
Yes.
Okay, so last week, we went over line, we went over rectangle, we went over circle, and we went over arc. So those were some of the real simple primitive stuff that we're going to look at. Today we're going to look at P-line, which is here. And then we have polygon, which is actually underneath the rectangle command. And then we'll take a look at donut and point, and I'm not going to use those too much. So we talked a little bit about P-lines last week. We did actually a command, which was a P-line. The rectangle command is actually a P-line. And a P-line can either be a polyline or a line or an arc. So the difference is, I think we talked about this last week. Let me get here. So if you drew a couple of lines using a normal line command, when you draw lines, let's say 1, 2, 3. If you're using the line command to do those guys are separate objects, okay? And they have an endpoint here and an endpoint here. And if you would go in and delete this line, these guys would still stay there. So if you did this as a P-line will be all one object. And wherever you start, it has a start point and it has an end point. So it knows the direction of this P-line from the start to the end. These guys intermediate, actually all of these guys, instead of referring to them as vertex or endpoints, they call these a vertex. So what we have a starting vertex, and then we have another vertex, and an ending vertex. Okay. So these guys can also be a little bit more complex. You can have an arc in here instead of just a line. So you could have a line to an arc. These guys can also have width. We talked about that last week, showed you that actually. But what that does is that pulls the polyline out this way, like this and this way. And it makes it look like it's, some people would call that thickness. But the true term is what we call line weight. Okay, so it gives it weight. And so at one time, the polyline was the only kind of object that would have this weight concept to it. So now you have weights, line weights that you can incorporate, so that's not as big a deal anymore as it used to be. So with the polyline, it has quite a few sub-options, so we're going to take a look at those. We're not going to use a bunch of them, but just so you get the idea kind of how these are working. By the way, there's 2 types of polylines. There is a P-line command. This is the actual name of the command, P-line. Polyline, this is 2-dimensional. So what this means is that all the z values of this guy are constant. So in other words, they will have the same value. You can't have this value z at 0 and this value z at 2 and this value z at 3. Okay, they all have to be the same. So they would be 0, 0, 0 or 2, 2, 2. The 3D poly is actually a separate command. well, let's see, let's spell it right. 3D poly. And this is actually a three-dimensional P-line. Okay, so the Z values can be separate. So what we're going to be looking at is this guy, okay, today. And we're not going to get into the three-dimensional one at all, actually. Okay, so if we look right here, this is the P-line command. Notice that's P-line. That generates a 2D P-line. If you really do want a 3D P-line, it's down here. Let's see, it's one of these guys. I think it's that guy right there. That's your 3D poly. Okay, so that would be a separate guy. All right, so if we do a 2D P line, it's just kind of like the line command. When you pick a point, it wants you to specify points. So I'm just going to eyeball a point. And I'm going to notice now that you're getting sub options: arc, half width, length, undo, and width. We're going to ignore that right now, but I'm just going to pick a couple of points here. And notice as I do that, those guys just come in like that, just like a normal line would. So we also notice that they don't look any different from lines, but if you click on this guy, you'll see that it is all one object. And of course, this guy's popping up telling me what it is. But notice those blue grips here, these are vertexes. So that's a vertex, 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 vertex. And because I drew it from this point to this point, this would be the starting, that would be the ending, okay? So that's a big difference than just lines, okay? Big difference. And the other thing, of course, is can have arcs incorporated into it. So we'll take a look at that here. So I'm gonna go, so while this is highlighted, I'm just gonna delete it, hit the delete key, and it'll take it out. So now if we give this guy width, what we can do is I come here to a polyline, pick a point, notice then I get the width option. So you have the half width or the width. They're basically the same thing because you might recall last week when we talked about this, the width of a polyline is always equidistant. So from the polyline or the line itself, you're going to be the same distance left and right of that line. So I usually just use width. So I'm going to go down here and give it a width value. So it wants to know a starting width and an ending width because we can taper this thing. So you could have a width of like 1 unit taper down to 0. So it would make like an arrow kind of look to it. But I'm going to have a constant width. So I'm going to give it the starting width and the ending width the same. So you'll notice on my screen right now it's at 0. I'm going to give it a width. No, don't make it too big if you're doing this with me. I would probably say, let's make it like about 0.5. And then it automatically, the ending P-line width will default to the starting. So I'm just going to accept that. So notice now as I draw, what I'm getting is a P-line that kind of looks like this. Notice also, it doesn't look very nice at the edges, but when we get done with this, as I hit enter and I'm done, notice it'll bevel it shut. So it cleans it up at the end. So the other thing is if we look at this, if I click on this and click on that P-line, notice that's where the actual vertex is. So there's no object out here or no endpoint out here or anything. So this guy is really just the way it looks. It has nothing to do with actually being that. So once you select a width on a polyline, it will remember that width. Okay, so if I go back into the polyline command, it's going to have that again. All right. So that's a wide polyline right there. So it's highlighted. I'm going to just go ahead and delete it. So I'm going to go back into the polyline command, and I want to show you a sub option called closed, because when you generate a polyline, you can either have it open or close, and I want to show you the difference. So I'm going to start a polyline, and I'm just going to come over here and generate it at a point, and then a point, and then a point. And I'm going to take it back to a starting. Actually, let me do this a little differently. Okay, let me see if I can do it just a little bit differently. So if you want to follow with me, you can. Yep. I'm going to start my polyline at a value of 2, 2. Hopefully that's on the screen. Yeah, it is. Okay, so I'm going to go 2, 2. Then I'm going to pick a point, and I'm pick another point, and then I'm going to type in 2, 2, and then hit enter. So I actually started at 2, 2 and ended at 2, 2, but you should notice as you look at my screen, notice how that didn't bevel shut, but the other two did. So even though we started and stopped at the exact same explicit point, this polyline, as far as AutoCAD is concerned, it considers it an open polyline. So if I close this polyline, actually using a polyline close command, watch the difference. I'm just going to pick a point, pick a second point, pick a third point. Now notice we have a closed option over here. So if I hit close, notice the difference. This polyline geometrically, they're both closed geometrically, but from a database standpoint, this guy is considered closed and this guy is not. Okay, it's a subtle difference, and you would not be able to tell that difference if you didn't have the width on there. So kind of an interesting thing. All right, so I'm going to take these guys out. I'm just going to select them, and then I'm going to just hit delete. So the other thing you can do with a polyline is what's called a length option. So if you give it length, what you do is you can just pick a point and pick a second point. I'm just going to leave my width on there because it's just kind of nice to see it. So if I want to just continue this in the same direction, but I don't know exactly what that direction is, I can use this option called length. And what that allows me to do is just tell it how long I want it to be, and it'll know the direction that it's going. Now, if you specify a positive length, it'll push it out this way. And if you specify a negative length, it kind of puts it on top of itself. So if I said, let's say 5 units, notice it shot it out 5 units. And here's the other thing that it did. It didn't just extend that line out. What it did was it actually attached another segment. So you'll notice if I click on my polyline, there's the vertex, there's the second vertex, and there's the third vertex. So I actually have 2 line segments, one right there and one right there. Okay. Turn that guy off so he doesn't keep popping up on us. All right, so that's what we would call the length option. Okay, so the other option that's kind of interesting is the arc. Now, arc option in Polyline is just as hard as the arc option is over here, you know, with the start, center, end, and all that kind of stuff. You have that same kind of thing. The one thing that is kind of cool about the polyline arcs, though, is that they're automatically tangent. So if you're just hitting endpoint arcs, it'll know what it's coming tangent from. So for instance, if I go into the polyline command and I start out in the line, I'm going to pick 2 points, and then I'm going to switch over to the arc option. And notice when I switch over to arc, you have angle, center, direction, radius, second point. So I'm just going to give it another point here. And this poly arc is tangent to that line. This arc is tangent to the last arc. That's tangent to the last arc. So all of these are going to be tangent. If I go back to the line command now, this line command is not tangent. So if I just pick a point like this, notice it's not going to be tangent. You can see that pretty drastically. So there's some cool options in there. Again, arcs are just as hard to use as a polyline as they are to use as just a normal arc. So normally we're not going to do this kind of stuff, and polylines we're not going to use as much anymore as they used to be used. Because again, at one time the only way you could get width on this object was to actually have it as a polyline. So one thing, if I exploded this object, I think I showed you that last week, but if I go up here to the explode option, which is this guy, or you can just hit the X key. If I type the explode, select my polyline, and then hit enter, it blows it apart. And because these objects are no longer polylines or poly arcs, they also lose their width. So notice we got that going on. There's a line, there's an arc. Okay, so you can see how that works, right? So you wouldn't normally want to take a polyline and build it and then explode it, because of course you're just killing that polyline. So it's usually not the thing that you want to do. So I'm going to select these guys, and then I'm going to delete them out. So I do want to show you, before we leave the polylines, one that's kind of cool thing about them is you can taper them. Tapering them is pretty neat. So I'm going to go in and start out with a line, and then I'm going to build that into an arc. And what I'm going to do with this arc is I'm going to taper it. So I'm going to give my starting width 0.5, but I'm going to give my ending with 0. So notice as I taper that, it looks like that. So that's kind of a cool thing. You can't do that too easily any other way. You can do some edits to edit them, but to generate them, sometimes it's easier to generate them. Okay. All right, so if there's no questions, we will move on. Ian, you good?
Nope, yep, I'm good.
All right, so let me see. I'm going to go ahead and delete this. And the next object we're going to take a look at is what we call the polygon. So let me just bop over here real quick. So one thing to understand with the polygon is it actually is a closed P-line. So it's actually not a new type of object. It's kind of like a rectangle, except it's a polygon. So let me just go to a new one here. Save this. Now what it does generate is what's called a regular polygon. Okay, so what regular means, so let me just draw this real quick. I'll try to draw this. I can't draw this really well, but I'm going to try to draw it. So the smallest polygon you could have is a three-sided polygon, which you would call a triangle, obviously. So this is called a regular polygon. So what that means is the distance around these are all going to be the same. So if that's 1 inch, this will be 1 inch, and that'll be 1 inch. The other thing is all of these angles in here will be the same. So this would be theta, that would be theta, and that would be theta, the same angle. And in this case, it would be 180 divided by 3 because the interior sum of a triangle is 180 degrees. So what you get is what's called a regular polygon. And the polygons can have a minimum number of sides of 3. And theoretically, there's no maximum number, but AutoCAD does have a maximum number. It's 1024, which is a binary number. I believe that's 2 to the 10th. So what you do is once you get past probably about 50 sides, a polygon just starts to look like a circle. And as I said, they're closed 2D lines, so they can actually have width brought onto those after the fact, so you can bring width into them. So there's two ways of generating them. One is called circumscribed and one is called inscribed. So for the circumscribed, what you have, so you have your polygon and you get this imaginary circle. I don't know if this will work. Yeah, that's not going to work. You have an imaginary circle. Let me just turn this off. That kind of is like this. That's a bad circle. But you have the circle. Actually, this is an inscribed circle. So the center point of the circle is this. The radius is the distance from the circle's center to the midpoint of your line on your thing. So this is called an inscribed circle. A circumscribed circle, what you would have is this is your circle and your polygon is circumscribed like this. So you have, again, a radius, and the radius is the distance from the center to the vertex of each point. And the vertex, if I had a circle running around this, the vertex of each one of these guys would be touching. So this is what they call a C for circumscribed, and this is an I for inscribed. Okay, so you have the two methods, the center point and the radius, and whether it's inscribed or circumscribed, and center point and the radius and the circumscribed option. So the other option, the third option, is what they call edge. And edge allows you to define a distance such as this. So I could start here, and then I could give it this distance, and I could generate my polygon in that method. So there's three ways of doing polygons. Probably most people do the center point first, but instead of this is a different option. So let's go take a look at those real quick and see. Again, you're not going to use these too much, these options, or actually this command is probably not as commonly used as some of the other ones that we actually talked about last week. But we find the polygon command built right underneath that, the rectangle. And notice when you select it, it says, okay, enter number of sides. So if you've never used the polygon command, like we haven't yet, it'll always have a number of 4 sides. So you're going to get a perfect square. In this case, I want to give it a little bit more sides. So I'm going to type in 10 and hit enter. So then it says, okay, do you want to specify the center of your polygon, or do you want to use the edge option? So I'm going to use the center option. I'm just going to pick a point. And then it comes back and it says circumscribed or inscribed. So do you want it inscribed in a circle or circumscribed about a circle? So I'm going to do circumscribed about a circle. And notice when I do this method, the circle is basically inside this polygon. So what I'm measuring is the distance from the center out to the midpoint of that. So the circle you don't see, it's actually an imaginary circle, but it will be inscribed or, you know, circumscribed about this. So if you give it a number, let's say 5, okay, so what that did was the radius is 5, and the radius is the distance from the center over to the edge on this guy. So if we do the second option, I'm going to do this again, just repeat it. I'm going to use the same number of sides, and I'm going to pick center point again. And this time I'm going to do an inscribed. I'm going to use the same distance, 5. These guys look the same, but they're really slightly different because one was an inscribed method and one was a circumscribed method. But what is true, the angle here and the angle here and the angle here at each vertex would be the same in both of these. What would be different is the length here from there to there would be different from the length from here to here. And you'll notice if I move this one into the other, you'll see that the one is slightly smaller than the other one. Okay. So again, these are two different methods. They're not as commonly used as an option as an object. If I click on this object, I just wanted to show you either one of those. If I click on this object and I list it, you'll notice it doesn't tell me it's a polygon. It says it's a lightweight polyline. And what you're getting is it's closed, like we just talked about. Notice the Z values are all the same. And what you're getting is an XYZ listing for each vertex. So this is vertex, 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 vertex. Okay. All right, so those are the inscribed option and the circumscribed options. Now, if we wanted to do an edge option, we just do this a little bit differently. What I would do, for instance, is go here, choose number of sides. I'm going to bop my number of sides down. I'm going to take it back to 3, and I'm going to choose the edge option. So what I'm going to do first is just pick a point, and notice when I pick that point, that's kind of like sticking a pin in at that point. And then what it wants to do is, okay, how big do you want your side, and what direction do you want that side? So let's say I wanted that side to be 3 units long at 30 degrees with respect to X. So I could type in at 3 for the distance, and then I would do a less than. So I would less than 30. And so what that, oops, I didn't take it because I did greater than. Let's try that again. 3 less than 30. Okay, so what this did now is it held that point fixed right there. The distance from here to here is exactly 3 units, 3 units, 3 units. And then this angle with respect to X here is 30 degrees. So that's the edge option. So the big difference is that when we did the other polygon, we knew where we were placing the polygon center, the geometric center of it. Here, we selected it based on an edge, so we don't really know where the geometric center is up here. And that kind of used to be a hard thing to find in AutoCAD, but now they have a little tool that will allow you to grab that geometric center. So I'll be showing you that probably next week. We'll get into that, I think, or the week after that. Okay. So that's the polygon command, not a big deal. And this could be exploded, or you could actually edit width into it. So you could either go one or two ways with it. But again, if you click on this, you notice it's one object. It's actually a polygon. So it's really just this kind of object, but it's just generating it differently. Okay. So now we're going to take a look at what we call the point command. So the point is really just used for a location of something. You can actually snap to it. When we get into what are called snaps, O-snaps, we'll be able to show you how to do that. I'm going to go ahead and select this guy first and delete him. So the point, the name of the command is point, P-O-I-N-T, or you can find it under here. they have what is called this guy, which is actually, that's actually what they call multiple point. So what this allows you to do is you can generate more than one point at a time. If you just type in the normal point command without using multiple points, you're just going to get 1 point and then it's going to knock you out. So we're going to use points in a couple of weeks on an assignment. So we'll come back to this, but I'm just going to show you this one. Again, it's not super useful. And one of the main reasons is that it produces a symbol of where your point is, where your location, but you can only have one symbol when you're in your drawing at a time. You notice that little red symbol that's showing up there, that's kind of what you're going to get. So there are, let's go back here real quick. I can explain it here a little bit. On the point itself, there are two things, like for instance, if I create a point, very simplistic point, this is a very simplistic point. So the center of that guy is where you're locating whatever your point is, and that's located in X, Y, and Z. So this thing can be at any Z value. And the point is governed by two things. One is called the PD mode. That stands for your point mode. And there are several different types of modes that they give you. And then what's called a PD size. PD size. And the size is the distance from here to here, essentially. That would be your size. And it can either be relative to the screen. So what that means is as you zoom in and out, if you have that size set to a certain value, it'll always look the same when you zoom in and out because it's relative to whatever your screen is. Or it can be an absolute value. So if I say this is 2 units, which would be huge, when I zoom out far away from it, it's going to get smaller and smaller and smaller. Okay, so there's 2 different settings. The modes govern how these look. So that would be one kind of point style. There's a point style that looks like this. There's a point style that looks like that, what they call a mode. And the easiest way to get to this is what's called DDP type. I'm going to show you a couple of places to get this, but if you just type in DDP type, you can get to this little box. You can also find it. I always got to look for it because it's not real readily available. They don't have it under here. I'll have to think about it, but let's go. I'm going to go ahead and just type in DDP type. There's another name for that's actually been renamed now. So it generates this box. And what you're looking at, these are the point modes up here. These are your PD modes. These are your styles of how they look. So notice you're limited. You have a dot and a no point, a plus, an X, and a line like that. You can have a circle with a dot, a circle with nothing in it, circle with your plus, circle with your X. So you can kind of see how they build. And the way these work, they're kind of weird the way they work from a binary standpoint. Let's see, is that 1, 2, 3, 4? I think it's 0, 1, 2, 3, 4, 5, something like that. But they start out, they have different numbers. We'll check those out. And then the sizes, notice here's your size. This says 5% of the current zoom. If you put this to this, it'll be in absolute values. So what I'm going to do is first, I'm going to set it to this. And we'll check that style out here in a minute. And I'm going to make that not quite that big. So I'm going to make that maybe, let's say 0.5. So once I set this up, it remembers that. So if I go into here and generate multiple points, there it is. PD mode is set to 2. PD side is 0.5. So as I pick points on my screen, notice what I'm getting. I'm just getting points like this. And wherever I place them, that's what I get. They all have, these guys all happen to have the same Z value because I'm not changing my Z. I'm working on that 0 plane. So if I listed them, that's all they would have. These guys can't be exploded. They're nice for mappers. I mean, that could mean like a sewer or a tree or something. But the problem is that we might want to use, is from a mapping standpoint, you might want to use all different types of point styles, and AutoCAD doesn't let you do that. Once you change your point style mode, it's going to change all of them. I'll show you how that works in a minute. And once I'm done, I can just hit the escape key. So notice this is just an object. It can't be broken down into anything else. I can move it. I can erase it. I can copy it, I can do all kinds of stuff like that, but I can't trim it and I can't explode it. Okay, so that's all there is really to that. Now, what is kind of cool, and I'm going to show you these tools a little bit later, but there's these guys here called O-snaps right here. And this guy will recognize what's called a node O-snap. So if I set this to node option on, and then I go into the line command, notice it's jumping right to those, so I don't have to do anything, and I can use these as little markers to describe stuff. So I can do that with them. So I'm going to undo that. So I'm going to go back into my DDP type. So notice we have this. So this is 0, 1, 2. That's how that got 2, 3, 4. And so if we wanted to change it to this, as I think this will be 34, 30, 32, 33, 34, 35, 36. It's weird the way they do them. But if I jump to this one and change that up and then hit OK, I want to use new styles. Notice what will happen when I hit OK. Those automatically update. So there is no way physically to have two different point styles set up in AutoCAD right now. And it's kind of a bad thing from my standpoint, because it's nice to have different settings. So for right now, that's kind of all we're going to do with these. I'll show you one other. There's a couple other tools in there that use these guys. So I'm going to go ahead and delete this. So let's say you have a line and you want to break this line down into a certain number of units, like say, oh, maybe 4 units. You want to divide that into fourths, but you don't physically want to break the line up. They have these tools down here that actually use points, and this guy right here is called divide, and this guy is called measure. So divide, if I go to divide, what I do is I just select the object to divide, and I tell it how many equal segments that I want. So let's say I want to have 3 segments. So what it did was it measured the distance from here to here. That's 1/3 the distance. This is another third of the distance, and this is a third. Now, notice when I did this, it didn't break up the line actually, but it did put a marker at the 1/3 point. So I could use that little O-snap tool like I just showed you. So if I wanted to place a circle right there, I could snap to that guy, and I could do it again, and just it snaps to it. So now I've got those circles at the exact locations at the 1/3, and I could then actually take this guy out if I didn't want it. So there's some cool tools in there. The measure tool works very similarly, except with measure, what you're going to do is tell it the distance that you want to go. So either from either end. So I could say I want it to go 5 units this way, and then put a marker every 5 units. And it'll either go this way or this way. So those are kind of what you might call editing tools, and the point tool is just a placement. Okay, so we're not going to use that probably on our next lab, but this last draw object we're going to take a look at today is called the donut. We are going to be utilizing that in our second lab. So I'm going to go ahead and take a look at this. Let me go ahead and clean my screen up. Just select everything, hit the delete key. The last one we're going to look at is a donut. And the donut in AutoCAD is actually, again, it's a 2DP line. But this 2DP line actually has width. So what you get with a donut, I kind of call it a washer. It's kind of I'm going to try to draw it, but if you have a circle here, and then you have another circle here, that's a really bad circle. Let's try to do that a little bit better. It looks like a kind of a washer, and what it'll do is it'll fill it in. So what you define is the center point of this guy, and you define this distance, which is defined as the outside diameter. So that's your outside diameter. And then you're gonna tell AutoCAD what this value is here, and this is your inside diameter. And once you define inside and outside diameter, then you just tell it where you want to place your donut. So it has some pretty cool applications, and we are going to use it actually on our next drawing assignment. again, it's one of those older probably objects and not used as much anymore, but there are some cool applications, so I'll show you that here. So let's go over to here. So we find the donut, it's also under here, and it is spelled, notice D-O-N-U-T. So that's not a misspelling, that's the way they spell it. So what you get is, notice it asks you to first specify your inside diameter. So the inside diameter obviously has to be smaller than the outside diameter, but in this case, it has a default value in there of 0.5. So I'm going to just accept it. And then it wants you to define the outside diameter, and it also has a default value of 0.1, or 1 rather. I'm going to go ahead and accept that. Once I do that, then I can just start placing my donuts. And that's really all there is to it. And once you get a couple donuts in or whatever you're doing, you got them. Now I can change the sizes. So if I go back into my donut, it's not like the point. I can define different ones. So I could say my inside diameter is 1, my outside diameter is 2. So I can have multiple types of donuts on my drawing at a time. So that's not like a point is. Okay. So these are polylines, and here's the weird thing about this. It's actually 2 arcs that have width. So if you notice when I click on this, there's your one arc and it goes from here to here. There's your top arc and there's your bottom arc. And what this arc is, it's got width this way and width this way. So notice if I explode this donut, what happens, it loses the width, and you'll see, okay, there's your first arc and there's your second arc. So it's kind of a complex thing, but it is a closed 2D P line with width in this case. All right. So from my standpoint, one of the coolest things about the donut is to be able to use it to generate what we call a filled-in circle. And at one time, and actually in AutoCAD, this was one of the only ways you could do it. So instead of having that donut look, or what I call a washer, when I do a donut, if you give your inside diameter value a 0, and your outside diameter is something greater than 0, such as 2, when I place this guy, I now get a filled-in circle. Okay, this is a highly useful tool right here, and I use this a lot. Now, do keep in mind, the edge of this thing doesn't exist. So if I have to be tangent to this outside face, that's a little bit harder to make that happen. AutoCAD won't find that real readily for you. You're going to have to do a little work. And in fact, that's one of the things we're going to look at when we get into this. So with P-lines, and I want to show you this one little tool that's really neat. The way they look on the screen is governed by a command called fill, F-I-L-L, fill. I'm going to generate another P-line right here, and I want to show you when you have P-lines that have width, and let me give this guy some width. Let's make this a width of 1. Okay, so I've got a P-line, got a couple different types of P-lines here. Donuts, filled in circles, and just straight lines. So if we type in the word fill, F-I-L-L, and hit enter, notice the fills are currently turned on. If you turn them off, and then you do what's called a regeneration, which I'll show you what that is here in a minute, RE, regen, this is what a non-filled in P-line looks like. So this one, showing you the edges, just remember the vertex is actually right in here. And you can notice how the filled-in circle looks versus how the donut looks. So AutoCAD printing is what they call WYSIWYG. What you see is what you get. So notice if we have this screen view right here and we print this, this is what the printer is going to see. It's going to see these, what we call non-filled-in P-lines. They're going to look like that. So normally you're going to want to have your fills on. So if I type in fill and turn it back to on, and then I type in RE for regeneration, it brings them all back. Now, here's another thing that you got to be careful with, and this is kind of why I told you not to mess with this guy. If I move this guy just a little bit, notice, let's see if I can get it to work. Every time I want it to, it won't. Let me try it. I'm going to just move it a hair. So notice it says top there, but it's my P lines are looking like that. And the reason is because they are they are set to not top down on. So if you want to fix that, make sure you're top down on. Okay. So I've had that happen where people just slightly move this guy, that view cube, just a little bit. It doesn't take much, and it looks like you're still top down on, but you get this look to it. So my fills are actually still turned on, but it's because it's not top. So Sure Top fixes that. All right, so those are the 4 commands that we're going to look at today in terms of draw commands or creation tools, objects. So we looked at P-line, we looked at polygon, which remember is below the rectangle, and we looked at point, which is here, and we looked at donut, which is at the bottom there. All right. We're going to be utilizing these guys over the next couple of labs, actually. So I think I'm going to have you guys use the P-line command and the donut command and lines and rectangles on our second one. So, all right, so we're going to now take a look at things like the new, the open, and the save. So we're going to look at these 4 guys: new, open, save, and save as. And remember, we can also get those. This is the quick access toolbar. We can also get these guys over here: new, open, save, save as. So I'm going to open up. Well, let's say I want to open up a drawing. Okay, so. Well, first of all, let's take a look at new. I should say that first. So new allows you to begin a new drawing. Now, you don't really have to use this command at all in AutoCAD. All you have to do is just hit this guy, and I'm in a brand new drawing. Okay, that's the easiest way from my standpoint. But what you have to recognize is what AutoCAD's doing is it grabs what's called a template and opens up that template, and then it renames it to a new drawing file. So you can think of a template file as just an AutoCAD drawing file that really doesn't have anything in it, but it does have settings. So every time you essentially begin an AutoCAD, it's using a template. So if, again, you just hit the plus, it's automatically going and grabbing a template for you called the ACAD DWT template file. If you want to use a separate template, what you can do is go to this command right here, and it's going to ask you what template you want to use. So by default, AutoCAD is set up to use this ACAD DWT, and you really don't ever want to get that corrupted. But notice there's a lot of other ones in here, and they've got some that have all kinds of things associated with them. And the reason you would have this, like say, for instance, if I go to this architectural tutorial one, if I open it with that, what I get is all kinds of things loaded into this drawing. And what you're noticing, I'm getting a title block set up. We haven't talked about this, but notice it actually brought me into paper space. Go back to model space. All these layers have been generated. None of this stuff was here in a normal drawing. There's all kinds of other settings that have been set up for you. So people in industry will use templates because they don't want to recreate the wheel every time they start. So if you're working in a company, and, you have enforced rules, like certain color schemes you want your people to use, and certain line types and those kind of things, you can create a template for that company, set that as the current template, and then you can go with it. So any drawing, any AutoCAD drawing file can be a template file. Now notice what will happen now, since I used that last time, that became my current template. So I really don't want that. So if you do that for some reason, if you use this, probably make sure that you go back to this guy, because this is the one that it's really set to by default. Okay. So that's all there is to new. So normally, like I said, you don't even need to use the new command. All you really need to do is just come up here to that plus, and that's it. Okay, so let's look at open. Okay, so open is used when you want to open up a drawing that you have already started on. Now, I know probably some of you are doing it this way. Like for instance, last week we started lab 1, and some of you are probably just finding lab 1 and double clicking it. So what that does is goes and launches the AutoCAD application. That's really not the best way to do it. Okay, the best way to actually The best way to actually open up a drawing in AutoCAD is to open up AutoCAD first and then go through the open command. So if I go to the open command, what this allows me to do is several things. This is a dialog box, and it's going to ask me to find the location of where I want my files, okay? And then it's going to ask me the file name to open, all right? So for instance, I have, let's say, a file I want to open in my desktop. I've got all kinds of stuff on my desktop. So I would navigate to my desktop. I think actually there's my desktop. And within my desktop, I have all kinds of folders out there. So let's say if I went to, let's say we are EVT. If I went to the EVT folder for spring, let's say summer 2020 last year, I could go, let's say, to that location. There's nothing in there in this case. Let me see if I can find one for this. That doesn't make any sense. That's not doing what it should. Let's see. Let's try and look. Let me see if it'll just, it's not doing what it's supposed to do. Let's put no name in there. Let me see if that'll find this now. So I'm going to go for a location, go to a folder. Ah, I know why it wasn't finding anything. All right, so notice down below here, there are file types. So AutoCAD can open one of several types of files, either a DWG, which is what we normally use, or what's called a standards file, or DXF, or DWT, which is a template file. So notice if I switch this to DWG, there should be a lot. Yeah, okay, notice there's a whole lot more in there, okay? So if I wanted to grab, let's say, this file, I would just click on that. It shows me a thumbnail, and then I just hit open. And it'll tell me the name of the drawing up top here. It'll also show it to me in that tab, and then I've got it. Let's go back to that open. So also, again, we said there were different types of file types. A DXF is what's called a drawing interchange file format. So that was a type of file that was created back in the early days of CAD, because early 90s, you had all these different CAD vendors out there, but none of them could share information with each other. So if you were working on a platform called CAD Key, and then somebody else is working in AutoCAD, you couldn't share information. It wouldn't open it up. So the CAD companies got together and federal government and created a language that they all could understand, and it's called a DXF. So I can create a drawing in a DXF format, and then I could give it to somebody that wasn't using AutoCAD, and they could open that file up. So it translates it. So it's kind of like translating something from French to German and then from German into English, if you want to think of it that way. So it's just several different translations. But it's just like any kind of translation. Sometimes things are lost in translation. So there are certain objects in AutoCAD that may not transfer right over to the other type of CAD. So it's not a perfect way of doing things, but it is a method. Okay, so that's what Open's used for. So notice here's the other thing too, is that when you open up a file, you can come over here and you can tell it to open the entire file, or you can open up as read-only. So if I open this up as read-only, what will happen, this file is now locked. So what that means is I can't save to this file, okay? So if I go out and draw on this, I mean, I can draw all kinds of stuff. I can draw a circle here and a couple of lines. It'll let me do that. But when I go to try to save this file, it'll tell me that it's locked, it's protected. So I can't save to this file directly. So that's kind of cool if you don't want to corrupt the file, but if you've made changes on it, you can't save them. So that's where you can save it with a different name. So if you save it as a new name, then it'll allow you to do that. So if you ever get that situation that happens, that's what's going on. It's got a lock on it. Now the other thing that'll happen, just to show you, you can open this once, but if you open it twice, the second one will be locked. So for instance, if I open this as a normal open, notice this is an open file. If I open it again, it'll automatically be locked. if it lets me do it. Yeah, so that one's automatically locked, and this one I could save to, this one I could not. So that's kind of a nice thing. All right, so that's what open does for us. It allows us to open up a file that already exists. As I said, DWG is the primary file type that it'll open, but you can also open a template file, DWT, which really is exactly no different than a DWG. And then that DXF, which is a unique kind of file that has been created through some other CAD vendor. There are different, by the way, versions of DXF that are out there. Okay, so let's look at the two saves that we have. We have the save command, this guy, which is actually the QSave command, and we have this guy, which is the save as. So if you have never saved a drawing, you're going to have to give it a name. It will, at that point, actually go to the save as command. So I'm going to open up a new file just to show you this. If I go to, let's say I create a circle, and I've created, let's say, a polyline that's kind of zipping down through him like that. And I now want to go to save this. If I go up here to save, that's your QSave command, quick save. At this point, it says, well, you've never saved this drawing, so you have to give it a name. So I can save it to a location, and I can save it with a name. So if I wanted to call this, let's say, Decker. Once I save this, it'll tell me I'm actually working on the Decker drawing, and now it's an actual DWG file. So now when I go up to this quick save, notice it doesn't ask me anything, it just saves it. So you should periodically do this save up here. Okay, so once you've given it a name, and if you're as you're updating, so when I delete something out, you know, like every 5 minutes, it's always recommended that you save, do a save, do a save. So every time you're saving, one thing that's happening that's kind of unique. Let me see if I can go to my folder here real quick. I don't know if it'll let me do this. Let me go to my desktop. Okay, I think I'm down here. Every time I've saved, there's actually two files happening. You'll notice there's the Decker drawing right there, which I just saved. And then there's my Decker BAK file. So that file, this file right here is the actual file I'm working on. This file is one generation removed. So every time I save, you'll notice the timestamp there. This one is actually like, say, like 5:05:31 or something, and this is 5:05, I don't know, 32. This one will be actually the older one. So if you don't say, like, say every 5 hours, these guys will be 5 hours apart. So the cool thing is when you're saving, you're getting two files. And if this one gets corrupted or lost for some reason, you can take this file and you can rename it, and you can actually open it in AutoCAD, but you have to rename the extension from BAK to DWG, and then it becomes a valid file. Okay, so every time I do the save here, every time I hit that guy, it's creating both the parent DWG and the backup. Okay, every time. All right, you guys get the idea how that's working?
Yep.
So another cool thing with the save as, if you go to save as here, so you can save it to a new location. So this is the location of where you're working. This is the name of the file, and this is the file type. So for instance, if you want to save this as a DXF file, I can come here and I say, well, I want that to be a DXF file. Go ahead and save it. Notice it shows me DXF, and it still keeps working like normal, but what you're getting is a DXF every time you're doing a save. So if I come up here and do a Q save, quick save, it's a DXF file. You guys won't want to be doing DXFs, but if you were sharing that with someone else, that's how that's useful. Okay, so probably the two commands you guys will be using the most is the open and this. Oh, there's a couple of things really I wanted to show you. I forgot to mention with open. Besides opening it as a read-only, you can also do what's called a partial open or a partial read-only. So if you have a really large file, a lot of data, you can actually open just a piece of the drawing instead of the whole drawing. That's what the partial open does. Then you can do what's called a partial read-only. Okay. All right. And again, I know a lot of people when they are starting in AutoCAD, dealing with opening, it's better to open up AutoCAD first and then launch your drawing through the open command. And the other thing is when you're saving, try to save to the hard drive and then copy to a flash drive or an external drive. What a lot of people will do is they'll put their flash drive in their computer port and then they'll do a save as to that location. And that's not a really good thing to do. Okay, because what a lot of people do when they get done, they'll just pull that flash drive out, and that's not good. Maybe you can actually lose data or fry that flash drive. Okay, so, all right. So, by the way, I guess I should mention there's, besides the BAK file, sometimes while you're working, you'll also see a DWL file. That's a lock file. That's a drawing lock. So if I open a drawing twice, or actually even while I'm working, there's a lock file that's generated. Sometimes you guys will save those lock files to yourself and try to open them up. They're really nothing. They're not a drawing file at all, okay? Or sometimes people send me lock files, DWL files, and those don't do anything for me. So a backup file won't open, and a lock file won't open. Those are the two things that are important. Only the DWG. Okay, only that DWG. All right, so we're going to take a look at a couple of things here. Let me just migrate over to here. Moving at a pretty good clip. So hopefully everybody's catching on to this. And again, if there's questions, stop me. I'm going to just go and take a look at a few things here real quick. So we're going to look at a couple of what we would call view type commands. Okay, we're going to look at the redraw and the regen. So we have what's called redraw. And then we have what's called regen, which is short for regeneration. And the alias for both of these, if you have a redraw, you just want to type in R. If you want to do a regen, you type in RE. Okay. So the difference is this is kind of how AutoCAD calculates things when it displays it on the screen. I'm not going to go into real depth in this, but what this does is just refreshes your screen. So if you have certain things that kind of look out a little bit out of whack, sometimes you can redraw them. It basically just kind of repaints pixels on the screen for you. But certain things need to be what we call regen. And one of those that I just showed you before was the turning your polylines fills on and off. If you just redraw them, they won't do anything. Whereas if you regen it, it recalculates it so it shows it. So let me just go over here real quick. And I can't get this to do this probably. Let me see if I can. I'm going to try to do something. Oops. See if I can get this to work. It never works when I want it to, but then when I try to go back, yeah, it's still not doing it. But let me just put my, let me put a polyline down real quick. And I'm just going to give it some real quick width so that you can just see what's going on here. Okay, so we have a polyline. All right, well, that's good enough. All right, so notice if I type in fill, and I just turn my fill off. Okay, notice that fill should be not showing up. So in order to make that happen, we have to force this regeneration process. But if I just do an R for redraw, there's actually something going on my screen, but it didn't do anything. Notice it even said that it redrew it, but it really didn't change anything in terms of the look. But if I regen it, which is recalculate things, notice it actually makes the difference. So usually if you have a choice, whether you're going to want to do a regen or a redraw, I would just probably do a regeneration. And that fixes things. So if I go back to my fill command, turn my fills on, again, notice a redraw does nothing, a regen fixes it. One thing you guys will notice, and I can never get this to do this, sometimes when you look at a circle, it doesn't look like a circle, it looks like a polygon. And the reason is that AutoCAD can display a polygon quicker than it can a circle. So what it does is it'll try to display it the quickest way that it can, and that is a polygon. So if you want to actually make that thing look like a polygon, or a circle, excuse me, you would have to regen it. So then there's a lot of calculations going on to display what's happening in your database, your object database, and then what your screen is displaying. And that's what that regen redraw thing's doing. So we're not gonna get too much in depth on that. But again, if we look at this, if you had a choice, I would probably do this one the most, because that one usually fixes things for you. So we're gonna look at zooms. And I'm gonna just kind of define these real quick. So the command zoom allows you to zoom in and out. So what it's doing is changing your magnification. So there's a couple of different ways to do it. You can use the zoom command, which is what we're going to look at. And the alias for this is Z. So you really want to get a handle on that. You can also use your mouse. And your mouse has that mouse wheel that allows you to zoom in or out. So that's called an IntelliZoom. Let's take a look at that real quick before we go to this command. So I've got my mouse or my zoom setting at a certain level here. Now the zoom that you're going to do with your mouse is dependent on where your cursor is. So notice my cursor sitting over here. If I zoom my wheel towards the screen, notice how it's kind of zooming from that point. Towards me is a zoom out, away from me is a zoom in. Now if I wanted to be it more on the objects, notice if I place it near that circle, zoom in on that circle, zoom out on that circle. So this is called an IntelliZoom. Okay, so that's a good type of zoom. You don't have to do anything, it's just all mouse driven, right? But you kind of have to make sure that wherever your mouse is sitting, okay, your position or your cursor, I should say, on the screen, that makes a difference in how it does it, okay? But the only thing, the downside to this is you don't have a whole lot of control. So that's where the zooms come in AutoCAD. You have more control. Now you have this whole section here called views, and they've got zooms built into some of this in here, but I'm going to show you the zoom is a lot easier to just do by typing. You can do some of the zooms over here too. They have zooms here. Those are zooms right there. There's a bunch of different ones. If you notice, if I click on that, there's all these guys here. Okay, but again, I'm going to tell you it's just simpler if you just type in Z. So we're going to go here. So let's look at some of the options. So you have what's called zoom all, and zoom extents. These are your two major zooms. Then you have what's called a zoom window. I'm not going to, by the way, show you all of these because there's some of them that, you know, you don't need a bunch of them. You can get by with just a few of them, quite frankly. Zoom scale. We'll take a look at zoom scale. We'll take a look at previous. Let's see. And there's what we call zoom real time. So they kind of went overboard, and there's actually more than this. There's a whole lot more as you get into this, but these are the major ones. Zoom all, zoom extents, window, scale, previous, real time. And you'll see more as you get into it. So let's look at these two first real quick, because these are the good ones to know. So the zoom all will zoom both your limits and your extents. So it looks at both of those and it gives you the picture based on where your limits and your extents are. Now this one can really bite you if your limits are set to a really low corner, but let's say your limits are really separately different from where your objects are. So let's say your objects are way out at like coordinates 10,000, 10,000, but your limits are set to 0, 0, 10, 10. So when you do this, it's going to look at both of those, and what you get is a real small picture, typically out in space. But extents ignores whatever your limits are, and it just looks at what the extents of your objects are. Oh, that's another one, by the way. I just thought when I want to do a zoom object as well. That's a good one. Object. Okay, so let me show you the difference here. So if I go to this and I type in Z enter, notice there's your all center dynamic. There's a bunch of them there. If we do a zoom all right here, notice it basically is giving me a picture that is the biggest picture that it can give me. Now the reason is because my limits are probably set to the same value. So in other words, my limits are probably 0, 0, and up here. And let's check my limits real quick. Drawing I can find. So notice my 0, 0, and it's at 7, 7, 5, 10, 10, and that's this corner. So effectively what's happening, the way this is drawn, the limits and the extents are the same. So notice in this drawing, sorry about that. So if I do a zoom all, and I'm going to do a zoom extents, there's going to be no change in the way they look. That didn't change anything at all. Let me see if I can find a drawing real quick to show you what can really happen if you've got really, really big differences in your limits versus where other things are. So let me see. Probably not going to be able to find something real quick, of course.
What about the one with the parking lot and there was like trees inside?
Yeah, that would be fine, but if my limits are set to that, it's not going to do what I want it to do. Also, that's the problem. Here, I think I got something here that'll work. That's a good call, though. But let me try something here. Okay, so I'm going to open up. Let's see. Okay, so I don't know what's going to happen here because this drawing is not. This is not a real true AutoCAD drawing. So it's going to take it a minute. Okay, so this drawing, all right, so there's the extents. So notice I have objects here, and objects here, right? Everybody see that?
Yep.
But I want you to, I'm going to check my limits here. So notice my limits are at 0, 0, and they're at 4,000, 4,000. So I'm going to do a zoom all. All right, so notice that's not the same thing as my limits. In fact, I'm going to check something here. I'm going to change my limits so they are sitting at 10, 10. Okay, so here's a zoom extents, and here's a zoom all. And that didn't change it much, did it? Of course it won't work the way I want it to. Yeah, well, anyway. But you notice that they're not the same is because my limits is different than my extents. So what it's looking at my limits, which are down over here, and it's looking at my extents that are over here, and it's displaying both of them. So what can happen if you're on a really, really big coordinate system? What can happen is these guys just get chucked way over here and they look real small. So if you have a choice between the two zooms, okay, usually what I'll do is I'll do a zoom extents because that's going to typically give me the biggest picture that I can get, okay? And again, all I'm doing is just typing in Z enter, E enter, or Z enter, A enter, okay? So that's really cool. So you can just do that very simply by typing. So let's take a look at zoom scale. Zoom scale allows you to give it a scale factor, okay? So if I type in Z, notice there's actually a scale option, but you don't even have to type in anything. All you have to do is just type a number. So if I type in 2 and hit enter, notice it zoomed in, or in other words, it made my picture twice as big. Now, by typing in 2, let's come over here real quick. When you do a zoom scale, so when you're doing the scale option, you have 3 methods of doing it. You can type in a number, or you can type in 2x, or you can type in 2xp, 3 different methods. They don't mean the same thing. So this is 2 times the limits, this is 2 times the current display, and this is only available when you're in paper space. So this is 2 times your paper. So right now we couldn't use this because we're in model space. So let's go back to this. So I just did a zoom. Somebody have a question?
Oh, nope.
Okay. So I just did a zoom scale. So I typed in 2 and notice it didn't do anything because I'm already 2 times the limits, because limits is a fixed quantity. If I do z enter 2x, this is 2 times the current display, and I can do that again, 2x and 2x. Okay, so there's a difference whether you use the x option or no. So I like using the x option because I have more control. So to get back, I could go the other way. I could say 0.1x, and that'll be 1/10 of the current display, and I can do that again, 0.1x. Okay, so I can go either way by doing that. All right, so you're probably won't use that one as much, but that's a good option once you learn how to do it. Okay, so again, we did zoom all, zoom extents, zoom scale. So now we're going to look at window. So when you do a window, what you do is you pick 2 points, and the size of that window determines how much magnification you have. So the smaller the window, the more the magnification. So notice if I want to zoom in around this, I pick a point and I pick a second point. So it zoomed in, but it didn't zoom in really tight. If I do that again, now I can just do it around, let's say, these 2 circles, zoomed in tighter. And ultimately, then I could do it again, just around that circle. So notice with this option, I can only zoom in, I can't zoom out. So that's a really friendly way of zooming. Just by picking the 2 points, making that window, the bigger the window, the less magnification. The smaller the window, more the magnification, okay? But you can't zoom out with a zoom window. So if I want to go back, I would have to do Z enter, A enter, or Z enter, E enter, okay? So I can do it either method. All right, so that's called a window option. All right, so the previous zoom, there's a zoom previous. If I type in Z enter, notice, I don't think that, yeah, they have a previous option. So what previous does is it goes backwards in time in every zoom you've done. So every zoom you're doing is remembered in what's called a zoom buffer. So this allows me now to zoom backwards, essentially, if you want to think of it that way. And it'll hold 20 zooms within that zoom buffer. So all you have to do is you just type in Z and then hit P for previous, and then Z, enter P. So all I'm doing is going backwards in time. It's not a real effective way of zooming, but you know, you can just kind of go backwards and see what you've done. Once you've done that 20 times though, you're going to clear the buffer, okay? Or if you've done 20 zooms, the 21st zoom will go into that zoom and the first zoom gets located out of the buffer. So it only holds 20 zooms at one time within the buffer. So it's kind of nice. I mean, if you just zoomed in and you want to go back quickly, you can just zoom in. Like for instance, I can do a zoom window. Whoops. I can do a real quick zoom window. And then I can go back where I was by Z enter, P enter. So I can go back, okay? So I certainly, I think it's an okay command. It's just not one you'll probably use too much. Now, one of my favorite zooms, which is kind of one of the newer zooms, is what's called a zoom object. So what this allows you to do, I'm going to zoom out to my biggest picture by doing a zoom extents. Let's say I want to zoom in on that word right there. So I can just do Z enter, object, select what I want to zoom to, and then hit enter. So it's kind of like doing a zoom extents right to those objects. Okay, so you can select more than one object. So I can do a zoom object and I can say, oh, I want to zoom to that object and that object. So notice how it does that. That's a really slick little way of zooming, particularly when you have a very complex type of drawing and you want to get to something really, really quickly. Those are great, great options. Okay, has everybody seen how these are working? I know where I mean, I can't see what you guys are doing if you're trying them, but
Oh no, yeah, makes sense.
okay. Now again, remember you got the mouse wheel too, so that's really useful. You know, I can do that. I'm doing my mouse wheel right now. You can't see it, but you know, it's real effective. Between that and like the zoom extents, those kind of things, those are great. Okay, so let's see what else we had. I think so we did extents, we did all, we did window, we did scale, we did previous and object. So let's take a look at real time. So the real time zoom is I don't know, it's kind of okay. I don't use it very often, but I'll show you how to use it. It's kind of neat. If I go into the zoom option, real time is actually the default right there. So to go into a real time zoom, all you do is type in Z, hit enter, and then you just type in enter again. So notice now I just get this magnifying glass. So it's kind of tricky the way it works. If you want to zoom in, you take your magnifying glass to the bottom, left click, hold it, and drag it to the top. And notice I'm zooming in real time. Okay? Zooming in real time. If I want to go the other way, I take the magnifying glass to the top, hold it down, and drag it backwards. Okay, so this is a zoom out. Notice if you go left to right, it does nothing. Okay, so top to bottom, bottom to top. Now it does have some really neat features. Once you're in the zoom real time, if you right click, you'll get these shortcuts. And you have 3 shortcuts associated with zoom real time: zoom window, zoom original, zoom extents. So if you want to do a quick extents, there's your click it, right click. Original will take you to the original view that you were in before you actually got into the zoom command. So if I do a zoom original, obviously it was an extents view. Now they noticed they also had what's called a zoom window. So window, if I do a zoom window, this window is a little different. What you do here, instead of picking 2 points, what you do is you pick 1 point, hold it, and then you release. Okay, so I just pick a point, hold it, and then release. So it's, instead of pick, it's pick, hold, release. So that's a little different. So once you get to the zoom, let's say I want to go back to my extents. When I want to get out of here, there's 2 methods. I can right click and then hit exit, or I can just hit the escape key. Either way works, okay? So again, you know, I'll be honest with you, I don't use real time as much as I use the other ones. I guess part of it is, you know, I've been using zooms for many years, and then, you know, the zoom real time came about maybe in release 12 or something like that, and so it wasn't one that I used all that much. So occasionally I'll use it, and a lot of times I don't. Okay, so those are the zooms. Any questions on this?
Nope.
Okay, so the last one we're gonna, well, actually I might do one more. The other thing we're gonna take a look at is what we call a pan. And so a pan, there's real two types of pans that we can look at. Let's see if I can, whoop. That isn't what I wanted to do. Let me see. Let's see if this will let me select that and then delete it. Okay, turn that off. Yeah, close that. All right, so we have what's called the pan command. And then you have what's called a real-time pan, or pan real-time. So the original pan command was kind of different. What you would do, well, first of all, a pan is allowing you to just look left and right or up and down, but it doesn't change the view magnification. So quickly, notice I'm panning my drawing around. I'm panning it to the right, I'm panning it to the left, but you notice that's what's not changing is magnification. So it's kind of like the concept of pan is panoramic is what that's short for. And it's kind of like, you know, having a camera and a tripod and you're just moving it left or right, but you're not changing magnification. So that's pan. So if you're doing it like this is called a real-time pan. You're seeing it happen in real time as you're doing it, okay? The other type of pan, and you have to do this, you have to type it in, but if you type in the word pan, you're actually getting this. if you type in a hyphen in front of it, you get the old type of pan. And so what I'm going to show you both of them, but what you would do is pick a point, and you would pick a second point, and the distance between those points would be the amount of pan it would do, and the direction between them would be that. So what you're defining is really a vector that you're panning with. That was the pan that was used a long time ago. So just to show you the difference. So the real-time pan is real easy to do. If you just type in P and hit enter, you're in a real-time pan. You just left click, drag it left, drag it right, drag it up, drag it down. Notice it's not doing anything other than panning. Okay. When you're done with this, you just hit the escape key. Now you can also use your middle mouse key. If you just hold your middle mouse key down, you're in a pan mode. You're in a real-time pan or an IntelliZoom pan. Just hold it down, drag it, okay. Now it looks, by the way, it does look like you're moving your objects around, but you're really not. Do you notice how my UCS is not moving with respect to my objects? It's moving with my objects, essentially. That tells me that I'm not moving objects. We're going to talk about actually moving objects instead of panning them, okay? So we're not changing coordinates. We're changing coordinates of our eye with respect to the objects. That's what we're actually doing, okay? So if you're trying that, hopefully you're seeing how easy that is to do. So you either just type in P and you just pan, or you can just hold your middle mouse key down and pan. You can also do it if you're in a real-time pan, you can right click, and what's kind of cool is you can go to a real-time zoom and then back to a real-time pan. So by just right clicking, you get a lot of cool things at your fingertips. Okay. So I'm going to show you the older style pan, and what this allows you to do is pan it differently. This is the way pan looked before they had the real-time. So to do this, you would have to hold the shift key and hit that hyphen, and then the word pan, you would type that in, and then you hit enter. Let's see, it didn't work. Maybe it's don't hit the shift key. Try that. Try the pan in front of it like that. Try that. Okay, that's what I'm looking for. All right, so notice it says base point or displacement. So if I pick a point, and then I pick a second point, notice when I pick the second point, it toggles off in that direction, but it does it as a secondary step. So it's not the same thing as this kind of pan. That's a real-time pan. Again, to do what I just did, you have to pick a point. That's my displacement vector, and the object goes in that. That was the way pan used to look before they brought out what they called the real-time pan. Okay. So I don't use a lot of real-time zooms, but I use a lot of real-time pans. They're just easier. Okay. Any questions anybody has?
Nope.
Okay, so that's what we wanted to get into for this week's assignment. So let me do something here. I'm gonna